What up? All right, we're going to do entry 3. This is activity series solubility rules. So basically, will single and double replacement reactions occur? I made some notes here already, and then we're using these down here. So remember, activity series, this is for single replacement. And the element, the metal that's by itself, that's the thing that has to be higher. So right here, these two realize that just because Ag is second in this one doesn't mean that copper has to be higher. It means the thing that's by itself has to be higher. So K has to be higher for this to happen. I go look, is K higher than Na? There's K. There's Na. Yep. So there is a reaction. It will happen. Okay. Is Ag higher than Cu? There's Ag. And Cu is right above it, so it is not. So that one would be no reaction. And then here's nickel higher than magnesium. So I'm looking, is nickel Ni? There's Mg, there's Ni. Nickel is not higher. So that would be no reaction. Okay. So single replacement, hopefully that's pretty straightforward. You could write the products here if you wanted to, but there's no pressure to do that. So this one says balance the following equation. That's good practice for us. Label the products as aqueous or solid. That's the most important part here. So I'm going to go through each of these individually, and we'll just go rule by rule. So the first rule says all inorganic acids are soluble. So basically anything that starts with H for us are any acids are soluble. So I look through here, I don't have any of those. Okay. All acids are soluble. Second one, all alkali metals. If I see anything from the first column on my periodic table, so that's H, Li, Na, K, Rb, Cs, Fr. Those things are soluble, which means aqueous. So I actually have one right here with sodium, so that one's aqueous. Okay. Going down to my next rule, acetate, perchlorate, chlorate, or nitrate compounds are soluble. So I'm looking for ClOs and NO3s. I don't have any of those. Okay. Next, we have Ag, lead, mercury, silver, lead, mercury. Those compounds are insoluble or solid. Do I have any? I do not, so that doesn't help me here. Okay. Next one says chlorides, bromides, and iodides are soluble. That means aqueous. So I have a chloride right here, so that one is aqueous. It doesn't help me with my other two rules. Next one, I'm looking for, I got hydroxides right here. Okay, so hydroxides are insoluble. It has a star next to it, so if it's a hydroxide with calcium, strontium, or barium, those are soluble. Okay, so OH is solid except when it's with Ca, Sr, and Ba. And as I look here, it's with Fe, so that tells me that is a solid, insoluble. Next, I'm looking for something about zinc or S. It's going to be a sulfide rule with an S right here. They are insoluble except when calcium, strontium, and barium. It's with zinc, so that tells me that this is solid. Will the double replacement reactions happen? Yes, because we have at least one. We have one solid. I'm going to say product. Okay. Nice. Oh, balancing. This is a good review for us. All right, so here I got two NAs. Over here I got two NAs, so that's okay. Here I got one zinc, so that's okay. Here I got one S, one SO4, one SO4, so that one's actually balanced as it is. Okay, so I don't have to put any, I could put ones there if I wanted to, but I don't have to put anything. Now here, I got multiple things that aren't equal. I got one Ca, that's great. Two OHs, and then three OHs. So I got to make those into the first number they're both going to, which is 6. So 2 goes there, 3 goes here. That gives me 3 CAs, so I need a 3 on this side. It gives me 6 CLs, so I need a 2 here. Oops. Gives me 2 irons, so then we're good. All right. Now, this is a good review for our predicting products part. So the first thing that's got to happen here is I got to write the products. Okay, so one thing to note, I'm just going to kind of break this down a little bit. Ti and K are going to switch spots, right? Okay, so I'm going to just start by doing that. The 2 might go away. I don't know if that's aqueous or solid yet. I don't know if that's aqueous or solid yet. That 3 might go away. Okay, so now I got to look for charges of stuff. I'm going to start with this one because we're going to be able to find those pretty easy. Potassium right here is a +1. And ClO3, chlorate right here is -1. So that one, the +1 and the -1, they cancel out. So I just get KClO3. Great. Next, I got titanium, which I'm going to have to figure out the charge of, and sulfite, SO3. So when I look at sulfite here, it's SO3 with a -2. And titanium can be a 3 or a 4, so it depends on what I see on this left side. So notice there's a 3 right here. When I crisscross, that's coming from my titanium. So that tells me the charge of titanium is +3 here, and the charge of my sulfate is -2. So when I crisscross, the 2 comes down here. I get Ti2 and SO3, and a lot of us might put a 3 right here like this, but that's 33 oxygens. So when I do that, I have to put my polyatomic ion, sulfite, in parentheses. So I need 3 SO3s, and that's what I see right there. Okay, so that's the hardest part about this. On the test, you won't necessarily see that for these types of problems, the solid or aqueous part. But the one thing we are working on here is predicting products, which is something that you will see on the test. So there'll be at least one problem on the test where you have to predict the products for our double replacement reactions. So now I'm looking to identify solid or aqueous. So first one, all basically acids are soluble. I don't have that here. Alkali metals such as potassium are soluble, so that tells me this one is aqueous. Oops, I don't know what happened there. And then next, I'm going for titanium or sulfite. That's the rule that I'm looking for. I don't see anything about titanium or sulfite there or here. Here I find sulfites. Okay, sulfites are insoluble, no exceptions, so that one is a solid. And then, hold on, we'll do that. Will the double replacement reactions happen? You bet. With the titanium compound, titanium 3, this is the name of it. Sulfite is a insoluble product. That's how I know. An insoluble product. Thank you. Correction. Okay, so now here I got to balance quick. So here I got 2 potassiums, 1 potassium. I could start there, so just for the sake of this, I'm going to do that. That gives me 2 ClO3s. Over here I have 3. Okay, so 2 and 3 I have to make actually into 6. So that needs to become a 6 there to give me 6 Cl3s, and over here this has to become a 2. Now that gives me 2 TIs, good there, 6 Ks. So over here I need 6 Ks, 3 SO3s, 3 SO3s, and now I'm all balanced. That's a 1. You'd see it written like this in a nice product here. Okay, so that's our entry 3 homework key. Let me know if you have questions. Have a great day, guys.